Yeah, very good evening to all of you. And my talk is related to I just developed the nano composite coating for Tribo-Corrosion analysis and for automotive application. Basically, I targeted. So this composite coating, or you can say composite paint, both are means we can use in automobile body to improve their life and their mechanical property itself. Next slide, please. So this is the my background. We just give why we are choosing this topic and how we can conduct the experiments in preparation of paint. Then we can perform the coating on steel, mild steel surface, because in mostly automotive bodies are of steel or mild steel. And then result and discussion followed by the conclusion. Next. Uh, Next. Can you change the slide? Yeah, so background is this corrosion. It is a very huge phenomena occurs in the automotive bodies or in automobile sector, then wind turbine sectors, hydro turbine sector, nuclear reactors. This corrosion is a very important in a study and how to reduce the corrosion. Like you can see here, the below the car, due to the rain or dust, and in rainy season, this body is corroded very fast. And due to that, your life of the car is also reduced if you are not properly maintain it or not properly wash. So that is the why we have chosen this topic, how to develop a good quality of the paint and which can gives the more wear resistance as well as more corrosion resistance. So that is the two objectives in our mind to take this problem. And when we are talking about the wear resistance, then also the material loss, that is a kind of the degradation of the material, and that directly loss to the customer or loss to the company also. Next slide, please. So this is the methodology which we have involved in this study. So first we can select the raw material. So proper selection of nano material, that is very important. Then resin, that is a base for nano paint. Develop of the base nano paint, that is a base paint. And also we need the dryer, solvent and other additives, so that whatever the mixer we can make it by the by adding the nanomaterial in the paint system, it can be sustained for longer duration. It will not settle down due to that particular agglomeration problem. And then we can go for the how we can perform the we can synthesize the nanomaterial by using the ball milling process, magnetic stirrer and ultrasonification, and then make the paint. So ball milling is used to reduce the size of the nanoparticles which we are using. And by using the ball milling for 1 hour or 3 hours, we are increasing the surface energy of the particles. So we are trying to increase the surface energy. Also, we wants to know what is the best time for ball milling, which can gives the better surface energy for nanoparticles. So we, without adding any further your stabilizer, your system will be sustained, like whatever the nanoparticle we have added in the paint base paint system, it will be sustained for longer duration. And then followed by the characterization techniques, we can do it for powder, XRD, FESEM, FTIR, and also electrochemical analysis for corrosion test. Then further, these are the tests we have also performed. Tribological test, we can perform it as per the ASTM G99, the pin on disc tribometer. and the corrosion test we perform as per the ASTM G3, and adhesion test, that is whatever the paint or coating we can do it on over the surface. So crisscross structure we can make it, and through the pointed nail, and what is the adhesive forces or adhesion between the paint, either it can be peel off or it will sustain for with the body. So that adhesion test we can perform D3359. Next slide. So in ball milling, we have used the solvent like toluene, and we can perform for 60 minutes. And we just break. We are not able to continue run the system, and we just work on the 5-minute interval, and we continue it for 1 hour. And the ratio of the powder and to ball ratio we have used here 1:10 ratio, and speed we just kept constant 400 rpm, and that is also play an important role. That is a one parameter which we can check further in future. Okay, what is the effect of speed in ball milling over the powder size? That is also one thing we can optimize it. Next slide. So this XRT result we have only performed in that particular powder, whatever we have generated uh, through ball milling. This is the only check whether any property change due to the work hardening inside the ball milling, or other no change. So we have found that whatever the properties of the fresh powder, it was there, the same peaks we have observed in that particular ball milled HBN. So it is found that there is no change in the crystalline structure of the hexagonal boron nitride, even though we have performed the ball milling of for 60 minutes. Next slide. So further FTIR experiment we can perform to check whether any other chemical bond is formation or not. So this also ensure that there is no formation of any chemical bond after ball milling and before ball milling. Both the structure are more or less same. So in this further confirmation as per the XRD results confirm, there is no change in the ball milled hexagonal boron nitride, no change in the property in the sense, and pure hexagonal boron nitride. So means it will not affect in that particular paint system. Property will always same as pure hexagonal boron nitride and your ball milled hexagonal boron nitride. Next slide. So this SEM analysis we can see here, like very flake form structure of hexagonal boron nitride, and that is in nanometer range we have obtained by ball milling process. So you can see here before ball milling the size of the particles are bigger, but when after ball milling you can see all the size of the particle is in nanometer range. So we can say that it is a nanometer nano powder which we mix on the base paint system. Next slide. So further, after performing the ball milling, we mixed the powder or nanoparticles in the paint system. So these are the paint system which I received from the paint industry. These are the base paint, 3 types of the base paint, and we can different concentration we have added it and kept for 15 to 20 days. And you can see here there is no sediment of the nanoparticles in that particular paint system. It is very stable paint system which we obtained after ball milling. Next slide. So further, after making the paint solution, we just use the spray. Here, this is the your this reservoir where you can kept your paint system. And these are the basic means mild steel structure, and in which we just coat over 10:10 ratio for electrochemical impedance test. So we just use the tape in other area which we don't want to expose, and whatever the area we want to expose, we just kept open, and we just do the paint by using this spray, and we can perform the painting. As well as the similar for tribometer test, we want to calculate their wear resistance and friction. Then we make the paint system over the pin, and disc is used EN31, that is widely used in the automobile also. So we just pin on disc test, we can perform to analyze the friction and wear of developed coating. Next slide. So this EIS test we can perform. We can do the coating on with the paint of HBN of different concentration, and we just kept the time 30 minutes, and substrate, as I told you, 10:10 or substrate material is mild steel, and solution which we use 3.5% NaCl in salt water solution, that is used to calculate the impedance for corrosion analysis. Next slide. So these are the two plots which is very important to analyze the corrosion test. So next plot and body plot. So next plot, it is showing that in terms of your impedance, what is the change in there, and body plot is with the impedance with your frequency. So whenever you can observe that the very less curvature in that particular plot means it will fail very early. So more curvature gives the more corrosive resistance, means more impedance with more radius of curvature gives the more corrosive resistance nature. So in this case, whatever the sample we have made it, the various samples we have made it, and we have at different concentration like 0.1, 1.5, 0.25, 1%, 2.5%. These things we have added. But what we observed that when we added more concentration of hexagonal boron nitride in the paint system, then corrosion resistance is reduced. It is not that much good. So this may be because of the hindrance between or some adhesion between or agglomeration between the particles is more, because surface energy is more, maybe the chance of more adhesive in nature, and they can make some agglomeration due to the higher concentration of the particles. But when we you can see that when we are adding only 0.1 or 0.2 0.25 or in that range, then we can see here that 0.1, that M means the mild HBN, and this is your pure HBN. So we just check the pure HBN and mild HBN, what is the changes in the corrosion resistance, and found that the mild HBN, even we added the 0.1 weight percent in the paint system, it gives the better result as we adding the pure 2.5 HBN in the paint system. The same results we have obtained by the next plot. So it is good. We can say that we are obtaining the very good results for corrosion resistance with minimum concentration of the hexagonal boron nitride using ball milling method. Next. So due to that, whatever the best result we have obtained in the corrosive analysis or corrosion test by EIS spectroscopy, we have only tested those samples for tribological analysis. This is the pin holder, and this is the disc, and we can perform for 5-minute duration that particular paint, and the disc hardness is 60 HRC, and we have applied the 20 Newton load, and that we can perform as per the ASTM standard G99. Next slide. So in this case, you can see that we have tested the three, as I told you. We just tested for best result in corrosion test. So paint system we have tested, it will be failed very early. And then mild HVN 0.1. Because that mild HVN, we have added 0.1 weight% concentration in paint system, and it gives the very low coefficient of friction as comparison to the other solutions or other coatings. So it shows that lower concentration of mild HVN gives the better tribological test and better corrosive test in for paint system in automobile applications. Next slide. So these are the conclusions. So we have make the nano powders by using the ball milling process, and we just characterize those nano particles using XRD, FTIR, and SEM. SEM is used to check the size, shape, and size of the powder. XRD and FTIR is used to check their property, either any crystalline formation is there or any bond is formed after ball milling. But in this case, we have obtained that no property change after ball milling also. So in further, higher concentration gives the poor corrosive resistance as well as the poor tribological resistance because of the agglomeration of particles high because of high surface energy. But lower concentration gives the better corrosive resistance as well as tribological resistance. So we can add lower concentration. Further, few more tests is going on in this result, and most probably at the end of 2022 we can file one patent in this area. Thank you very much for patience listening.
Thank you, Dr. Katiyar. Very interesting talk, actually very exciting observation. And you have all the facilities, right, in your lab?
Yes, we have facilities.
Okay.
So we have pin on desk, we have 4-wall test rig, electrodeposition method. So these are my area actually here. I just work in tribology. I also wrote several books in the tribology also.
Okay. Tell me one thing, is there any specific reason to choose boron nitride?
Actually, in industry, what happened if we can go for MOS2 or graphite or graphene also we can choose. But the problem is cost-wise, graphene is very costlier, and also nobody can afford that particular graphene for addition. And also another further reason is it is a blackish in nature. So means after deterioration of the paint, we can't identify either it is deteriorated or not. But in the HBN, that is a graphite flake structure, and it also having the same property as graphite or graphene. So if some color will be changed, then we can identify easily that it is degraded. That's why it is a white in color.
Okay.